So 6.7 is the last section in chapter 6, and it's multiplying and dividing complex numbers. And this works out pretty easy. You just have to remember the distributive property. It turns out the distributive property works for complex numbers, just like it does for real numbers. So we'll use the distributive property, and we'll use the fact that I squared is -1. Remember, I is the square root of -1, so if you square it, you get -1. Okay, so first, multiplying. You distribute, then combine like terms using I squared equals -1. And you want to write your answer in standard form, which is A plus BI. And you can always do this. It always works out. Okay, so this is a general example. A plus BI times C plus DI, right? You would take A times, right? A times C. Let me do this real slowly here. A times C plus A times DI plus BI times C plus BI times DI. And the way I group these, notice the BI times DI, you'll get BD I squared. I squared is -1, so you get minus BD, and that'll combine with the A times C to give you the real part. So these brackets on the bottom show you where you get your real part from, and the brackets on top show you where you get your imaginary part. It's the inside and outside. It's like the middle term of a trinomial. That'll be your I term, okay? So you'll see when we actually do actual numbers. It comes out looking like this, which is kind of messy looking, but you don't memorize this. You just use distribution and the fact that I squared equals -1. So for example, multiply 3 minus 2i times 5 plus 6i. And implied in this is that you'll write your answer in standard form. Okay, that's implied here. Okay, so I just distribute 3 times 5. Oops, slow it down a little bit. So I get 3 times 5, right? And I get -2i times 6i is -2 times 6i squared. And then I'm going to get the inside and outside. 3 times 6i, that's this one. And then the last one's going to be -2i times 5. So that's where those came from. So multiplying these out, you get 15 plus 12 equals parentheses 18 minus 10i. You see what I did? So 3 times 5 is 15. This is -I squared is 1. I squared is -1, so the opposite of I squared is 1. So that means plus 12. And then plus 18i minus 10i is 18 minus 10i, or 8i. You don't have to write it out exactly this way, but I just decided to do that one that way. So I end up getting 27 plus 8i, which is in standard form. Let's do a second one. This is an important example. These are what we call complex conjugates. We did conjugates before with like square roots, you know. These are called complex conjugates because they're complex numbers. And they're the same real and imaginary parts. Well, the imaginary parts are opposite, -b and +b. And so they're the same two terms, except that one has a minus in the middle and one has a plus in the middle, which is called conjugates. So these are complex conjugates. When you multiply complex conjugates, what you get is a squared plus b squared. It's a plus because you would get a squared, well, maybe I wrote it out here. Let's see. this is what you get, right? It's the difference of two squares formula. So you get a squared minus bi squared, the whole b and I, the whole thing squared. Well, this gives you a b squared, and it gives you an I squared. I squared is -1. That cancels with the minus and gives you a plus. So what you actually get is a squared plus b squared. Like that. So without the i's, you get a squared minus b squared. With the i's in here, you get a sum of two squares. So that's a good thing to remember. If you have a product, and we have this quite often, if you have a product of two complex conjugates, you get the real part squared plus the imaginary part squared. Remember, the imaginary part doesn't include I. So the real part squared plus the imaginary part squared if you're multiplying complex conjugates. So that's really nice. That's an important thing to remember. Okay, it makes your work much easier on some problems. So here's an example. These are conjugates, right? A here is x plus 1. B is square root of 8i. So I have a minus b times a plus b. So I'm going to get a squared plus b squared. B is just the coefficient of I. So plus 8. So if I write that out, I get x plus 1, the quantity squared, plus 8. That's the answer, except I need to write this in a simpler form. Notice that's a real number. I multiplied two complex numbers. When you multiply two complex conjugates, you get a real number. Right? A squared plus b squared is a real number because a and b are both real. Right? So anyway, I get this, and then in your text they want you to multiply this x plus 1 quantity squared out. That's because the constants combine with, the constant 1 will combine with the 8. Right? So you get x squared plus 2x plus 1 plus 8. So that's x squared plus 2x plus 9. Okay, so that's how you're supposed to do ones like that.